waiting for you. Oh, you don't have to wait.
Thank you. Good morning. Also from my side, my name is Tomaž Savšek. I'm coming from the local automotive industry, TPV, and together with my colleagues Mitja and Willi, we prepared a presentation about the digitalization in automotive industry. The slides on the screen, they are in English. I will try to speak sorry, the slides are in Slovene. I will try to speak in English. I say try because my voice is very bad this morning. But anyway, I'll try to do at my best. As Borut mentioned already, automotive industry was mentioned a couple times this morning already. So one of the case or one of the pilots should be within this project should be done also in the automotive industry. So I will try to emphasize and to share with you some of the ideas about the digitalization, about the use of high performance computing in the automotive industry today, and of course what is the most important also for the future. So the context about the the context in my presentation will be about I will start with the so-called Digit Agenda. That is the agenda that was developed last year from the Slovenian Chamber of Commerce, and I was lucky to be a member of that group that prepared this agenda. So I will share some ideas from this agenda with you, and I will continue with the digitalization, especially in the business processes. I'll be focused mostly in the digitalization of the product development in the automotive industry, and of course it's very popular to talk today about the smart factories. So I will share with you the aspects, the point of view that how we understand, how we see the future factories, so-called smart factories, for tomorrow. As I said, the Digit Agenda 2016 was established last year. It is accessed, and you can see this agenda also at the web page. It is, you can see it on the slide. It is in Slovene language as well as in English. So it is very interesting also for this project, because the idea of this agenda is to prepare some recommendations from different areas, and to emphasize and to define what should be the objectives of the future digitalization in the different areas of our lives. So we prepare together with different people from different areas, not only from the industry, some recommendations about the digital infrastructure, what infrastructure would be needed for this digitalization process, what should do the industry, or what processes should be digitalized in industry, in service, in the area of services, and of course it's also important what types of regulations or which regulations should be changed in the future according to follow the development in the area of digitalization. And also we conclude also with some general recommendations as well. I will not go into details about all these recommendations. As I said, you can see that recommendations at the web page, but I would like for today I would like to stress out some recommendations from the digitalization of industry. And the first recommendation is focused with the so-called virtual factory. It doesn't mean that we will have only the virtual factories in the future. Actually, we won't have virtual factories in the future, but the goal here is to improve the control over all processes in the company. So how we can with the support of digital technology improve this control over all processes. The next recommendation is about the establishment of value-added chains via the digital platforms. So how to exchange the data, the ordering, scheduling, supply through the digital platforms to make stronger and faster the chain of so-called added value chains in between different companies. The next one recommendation is connected with the German so-called Industry 4.0. It's a very popular expression, and it was established in Germany by some experts from the industry, and later on it was supported by the German government, and as well later on also by the Europe Commission. So we follow in this document also the recommendations from the Industry 4.0, sorry, and as you know, the NUP region, also the Bavaria region is also a part of this project, so it could be interesting to follow these recommendations as well. And the main objective that we understand here is to how to make interoperable different types of ICT systems, how to connect different types of information and communication systems. That's for us the most important issue as we see these guidelines. And the next thing that is very important for us, that we see that is very important for us in the industry, is the so-called digital training in the industry. And the objective here is to provide additional education and training to increase the employability and to reduce the potential dismissal due to the digital incompetences. Because it's very often heard that with the digitalization, with the smart factories, a lot of people will lose their jobs. But we try to focus, we try to emphasize here that people should be trained for new jobs, should be trained for new types of work in the future, and also the Slovenian Chamber of Commerce realized that there will be opportunities for at least 10,000 new jobs in the next 10 years. So there will be not only a risk that people will lose the jobs, but there is another challenge, or there will be opportunity to get quite a lot of new jobs in the future. I mentioned the German Industry 4.0, and the point here, and the most important point here, is that we are not talking about we do not understand that Industry 4.0 as a revolution in the industrial revolution, but we understand it as a digital transformation of the business processes, and it's not so much connected with the new technology. So we are not talking about so much about the revolution of the technology, but we are talking about the evolution of the processes in the industry. And as we realized also in the company here, that company, it's not necessary to respond actually to every technological innovation, but sometimes it's much better to make an analyze in a company what are actually the key business processes, and try to increase the efficiency of that processes. So it's not necessary, if there is a new technology available, just run for that new technology and then skip to another technology. In the industry we cannot do that, but it's important for us to realize what are the key issues, what are the key processes in the company, and to digitalize that processes for the future to be more efficient. And we see that there are quite a lot of challenges in a company like our company, which work in the automotive industry, like how to provide advanced interaction with the customers, because we are not a company, especially in the automotive industry, that we can do everything by ourselves, but we have to communicate with our customers, with our suppliers. So how to integrate, the next challenge is how to integrate different sites. It's also not our idea that we concentrate all industry in one place, but it could be in different locations. But of course, how to integrate through the digital technology, through the computers, to provide this supply chain being more effective. And of course, as I mentioned, it's very important the knowledge of the people that work in the industry, and the awareness of people that the innovation is very important. Innovation of the processes is very important for the future industry. For us, as the development, as the company that we work in the automotive industry, and we are suppliers, and we don't like to be only the suppliers who provide some physical work, but we would like to be, and we are already involved also into the development processes in the automotive industry. So our customers, like OEMs, the producer of the vehicles, they communicate already with us about the new products, about the future products that will be produced in the next 5 years, something like that. And we are responsible to develop a certain part of that part of the vehicle. And in this process of the development of this product, there's a couple steps which are very important, and where we also, of course, need a lot of computer capabilities. We start with different types of research of the for example, of the requirements, what types of requirements, what are the state of the art in this area. Then we continue with the preparation of some product and product development. And as you can see, we already continue also with the construction, with the design of these types. And with the, when we have this construction, so with this design, everything is done in a virtual environment. And in all these 3 steps, of course, we do everything in so-called virtual reality, and we do need a lot of power capacity already today in this development processes. Of course, we then continue with the development of the production processes. We do different types of studies, preparation of control plans. We produce at the end also the prototype, physical prototype, which is tested and validated in a real situation. But what I would like to share with you now is to see a little bit more about those processes where the high performance computing is already needed for the successful development. The first, as I mentioned, is the preparation of basis for product and process development, where we have to go through the different steps, through the analysis of the different records, databases. we should analyze the legislation and our other aspects, and at the end of the day, we prepare a concept. It's done in a 3D environment, and later on, on this concept, we prepare different 3D models, then drawings, bills of materials, and all this work is done, of course, again in computers, in a virtual reality. Here you can see different also the software that we use, like CATIA and Dassault. And when we prepare this 3D model, we tested all this design and all these products in a so-called virtual reality. And I can say that all this testing are very high computer performance request very high computer performances. It takes a lot of time and a lot of capacities, because we have to test different types of deformations, resistance, endurance. We make a lot of fatigue tests, vibration and noise vibration harshness tests, and at the end also crash tests. It happens, of course, with the vehicles that crash happens, so we have to make a crash test as well. And all this is done, as you can see on the slide, by the software computer. Today, especially in the automotive industry, we use different types of programs. I mentioned here a couple times CATIA. It's a product of Dassault, and also some colleagues from the CAD/CAM company from Ljubljana. Davorka and Marko are here today with me. And if you have any specific question about those programs, what types of computers do we need for that, they will be willing to answer to your questions during the breaks, or also later on at the round table where Davorka will participate. When we prepare this product, of course it is necessary to do another step. Another step is to prepare the process, the production process of this product. Our company do not only develop a product for the customer, but we also, and that is our main mission, we also produce that product, and we produce that product in thousands per day. And of course, it is very important to develop also the tools and machinery for the big volume production. And for that purpose, we also use high performance computers for 3D models, for the drawings, bills of materials, to develop the design of that tools and machinery, and of course later on to test this machinery, at the first step in virtual reality, and later on, as you can see the last picture, later on also in the reality. Why we do all these things in virtual reality? The reason is costs, of course, and the time. It's much easier. It's cheaper to test all these materials and products and machinery in virtual reality, and it is also faster than to make a real model or a real machinery and test it in a real industrial environment. But of course, at the end of the day, again, we have to produce real machinery and make real tests in the industrial environment. Now we are coming to the very popular area, and that is so-called smart factories. some people understand smart factories as it shows this picture at the bottom. So in the future, people understand these smart factories that in the future there will be only robots, fully automated production lines, no people, no sunshine, no sunlight in a factory anymore. But we understand these smart factories a little bit different. First of all, we understand that we should take care about the data acquisition and to provide all this data available for all processes and people that are involved in the production process. We understand the smart factory as a very important transfer of knowledge from people to software, to machinery, and then back again to the people. So then data processing and decision making in real time, it's very important that we have data available to make fast and precise decisions. And we see this added value, especially in the construction of smart manufacturing environment and availability for communications of machines with other surroundings. There are some examples that we stress out what we see in our company, what would be the challenges or the future about the automatization or robotization. The right side, there's also the picture of the automated guided vehicle that it was developed by our experts, and it is already available in the market. And it is very useful tool in the internal logistic to provide the movement of the material from one point to another point. Just some examples of the one example of the so-called smart factories, what we do in the area of the automatization. You see that from the virtual reality to the real industrial reality, we can provide the development of the certain machinery, certain tools. At the left side, you have the picture from the virtual reality that was produced in high-performance computing, and at the right side, the realization of that product already in a real situation in the real industry. Smart factories, it's actually some kind of pyramid from the technological process level through the local control level, data acquisition level, up to the business level, where we collect all data and where we share those data in between different levels, so we can communicate with every different machinery, people, and management at the end. And of course, high performance computing is requested here, and it is very important part of the future factory. About our company today, where we are concerning the digitalization or the use of information technology and computer technology today, I should say that our company already in 2009, that's 7 years ago, we got the TPV was awarded for the achievement as the best company in Slovenia. And that award we got for the realization of the so-called EDI process. That's the electronical data interchange, which provide the exchange of data in between the company and our suppliers on one side, and the data with our customers on the other side. So we can exchange different digital data about the forms of the delivery, invoices, data about the new products, and all other things which are very important. And we are very proud that we got this award at that time. So we could say that we have quite a modern ICT environment, and that we are somehow ready for the future, for the new challenges. And the new challenges that we see for tomorrow are connected with the manufacturing execution systems, with the warehouse management system, VMS. As very important is also the business intelligence, BI systems, and the area of the automatization and robotization of process for production processes. I should say that already today we have more than 150 robots, different types of robots, and for the next 5 years we plan to have more than 400 robots in our production sites, and that's the only way to be competitive in the future. So let me conclude with this slide. This slide also, you can see that it's also our leading slide in our presentations, from the virtual reality through the from the digitized production to the vision for the future. Thank you very much, and have a nice day. If you have any question, is there time for the questions? No? Okay. Yes.
For this interesting lecture, I hear the first time that actually you can do this testing of cars virtually. So have you verified that it works the same as in the real testing?
Yes, that is very very important question, a very important issue to test the every single part. Also the crash tests or some other tests, fatigue tests are also very important, and it's very important for us that the results from that test are quite similar or very similar to the real tests, and we can do that if we have the knowledge and expertise from the real tests, from the previous real tests, and we put those knowledge or those experiences into our models, like Abacus, I mentioned this, that we put all this knowledge into the models, and to make the next generation of the tests with an additional knowledge. And that's why it is very important for us to be in a connection also with our customers, with the OEMs, which provide us some results. And it is also important for us that we have our own databases where we can get those data from the previous simulations. And the fact is, we are lucky that the automotive is rather traditional industry, so there is no, from one generation to another generation, is no every new vehicle is not a big revolution, but it's evolution, and we can use all these experiences from the previous experts or from the previous use of the vehicles. Thank you. We do. I'm not quite sure about the number of this, but it's for example, we in the middle of last year we got a request for our OEMs to make some development of a certain part, and on the base of that request, we made the first simulation, and during the first simulation, we already got some changes. So we had to repeat this about 10 times to come to the final solution, and that was just because of the changed requirements from our customers. But when we have a high-performance computer, it's easier to to change some parameters and to see the results. But sometimes it takes, when we start the simulation, it takes about 2 or 3 days to get the results from that computer. Of course, if you use, but we use our own computer for that. It's not typical high performance computer, but in the future it seems that we will need much more high performance computer capacities to do that faster.
There is room for cooperation?
Of course, there is a room for cooperation. I show you some slides. We cooperate with the faculty of machinery in Ljubljana. They also have a high performance computer. We have some results. We have some projects with the faculty for the informational studies here in Novo mesto. We also cooperate very close with the faculty for industrial engineering. The vice dean is also here, and that is the solution that we see for the future: cooperation with others. Okay. Thank you for that question. It's very important to establish the trustness between the partners, trustness with the industrial partners and the academia, and that trustness can be established through the long-term cooperation. That cooperation cannot based only daily base requests. Sometimes people also in industry, they would like to have some answers in 1 second and just go to the. We cannot go with that questions to the open market and try to find the answers. So we have to invest a lot in the long-term cooperation with the faculties, with the research institutes, and on that basis, when we trust to each other, and of course we also sign the documents, but non-disclosure agreement and things like that. But of course, at first, it is important that we have this trustness, establish this trustness. And I think that also, I know that in Romania you have a lot of industry, especially Dacia, for example, and you have also a lot of opportunities because the Renault decided to develop the research development center in Romania, especially to develop the process, the production process. Design will be developed somewhere else, but how to produce that in the most efficient way, there's quite a lot of opportunities for the Romanians and of course also for the people from the academia to cooperate in that area of high performance computing as well. Thank you.
Dr. Savšek, thank you very much. Thank you also for the interesting questions. Now, I think there will be more opportunities to debate later on during the coffee break, and especially during the roundtable discussion at which Dr. Savšek also kindly agreed to participate.
Okay, thank you once again.
Thank you so much. Now I will give the floor to Mr. Tomi Iljaš, who had some travel problems, but now he's here and he's ready. He shared his rich.
I'm not yet rich yet, but
just expertise is rich. If he's not rich, then I'm not talking about market value of expertise or experience. But anyway, Tomi is the director and the owner of, I think, the only company in Slovenia, and maybe one of the very few who's actually actively in the market of HPC, actually owning the infrastructure and doing lots of EU-funded projects as well. But Tomi will explain more about that. I'm just trying to talk so they have things set up.
okay. Thank you very much for this great. Should I use this? Okay. For this great introduction. Sorry for my delay. I'm always kind of bad in planning, so I always think that the route will be empty with no ice, with no trucks, and with no Bora wind, which was the main issue this time. Okay. Nice. So I'll try to talk about an issue: how to deliver HPC services to small and medium enterprises. So we are dealing with this for the past 8 years, and it's not simple. Not from the technical point of view, but the all other stuff. So. And I will try to show you some other European projects or initiatives which some of you are very well aware of, but we are actively involved in many of these projects, so I can give you the first information from the first hand. Okay, usually what I do, because I'm old enough to witness the development of the internet era. So I'm trying to compare the internet era with HPC era. So you remember, not all of you, many young people in the room, but you remember when in beginning of 90s, big industry started to use internet, and then smaller and medium enterprises started. And then at the end of 90s, somewhere, the households started to use internet. And at that moment, the big business began. Before that, there were just a couple of people, one here in Novo Mesto, one in Nova Gorica, etc. We were trying to sell these internet connections. We were trying to sell web pages to the small and medium enterprises. So if you ask me, the HPC, it's now somewhere in the stage of the yellow one. So we are trying to offer services to small and medium enterprises. Large enterprises are using it for years now. Universities and military, of course, even longer. What is important here, that here the business starts. And at the introduction, at the beginning, it's true, we are one of the few commercial HPC providers in Europe. Why? Because this is not yet a business. When this will become a good business, then many private-owned HPC centers will arise. And of course, you can imagine when citizens will start using HPC for, I don't know, DNA analysis, medical, whatever, multimedia, then the real business will become. Okay. So when you try to provide HPC services to researchers, to the people who know what parallel programming is, people who know what MPI is, then you have these 4 steps. And we are doing this even for government-owned organizations around the world, because if they need really high priority service, then they come to us. And they pay, of course. Nevertheless, they have a lot of much larger infrastructure for free, but there are queues. And if they have to wait a lot, and the I don't know, industry partner is waiting, then they're coming to us and they purchase the infrastructure. If we try to compare this with small and medium enterprises, then we have like 5 steps, at least 5 steps before that. So what we do at the beginning, we are we are basically, we go to entrepreneur, we say, oh, you need HPC, he says, or he or she says, no, we don't. Yeah, you do, because your competitors are doing this and this, and if you don't start using HPC, you're going to be dead in 5 years or so. And it's a long process. Sometimes they even change the production line. They even start thinking in other markets, in other products, etc. So usually these 5 steps, we spend like 1, 2, or even 3 years before we come to the first real step, which is we start charging our services to these end users. So what we do here and what we need, it's not just infrastructure. It's also a combination of infrastructure and the software, and of course a lot of competencies. Not only about the hardware, I mean the infrastructure. It's also about the software. I mean, like CFD software we saw today, or even domain experts. So we always, when we try to provide these services to small and medium enterprises, we try to combine all 3 layers. And with our network of excellent universities and other research centers, we try to bring all these to the small and medium enterprises, which usually cannot afford to buy, to have like 5 PhDs working on research center, etc. So it's important for SMEs to offer the full service, not just the bare metal. When you try to sell the bare metal to SMEs, nobody will come, I'm sure. Okay, so imagine barriers. We have heard a couple of barriers from the previous speech. Imagine one engineer trying to do some simulation, trying to build a new aircraft. They have good company, they know what to do, they see the niche in the market, and they will try to build a new aircraft. Of course, nowadays in 2000, whatever, in this millennium, you cannot build a new aircraft without excellent simulations. You can build, actually, but it will not be the best in the market. And the first thing which will hit this poor engineer will be the price of the software. When you try to use CFD or other softwares in your desktop, it will cost you what, 2,000–3,000 euros. If you try to use this in a large machine, it will cost you 100,000 euros, 200, 300. It's up to, it depends on what you need. The second one, it's hardware. You have to buy something, and it's capital expenditure. So you have to invest money, and then try to get money back through the research. And of course, at the end, domain know-how, you need other experts from the various fields, and you come to the big issue, the big barrier, which is trust. We have heard, and I'm very glad to hear this. You know, you need trust, because you will not gonna send all your data, all your geometry of the new aircraft, which will be the world leader, to somebody you don't know, you don't trust. I mean, not in technical terms, in real, you know, face to face, in person to person terms. Okay, so we have a lot of these challenges, and Europe is well aware of all these challenges, and they are heavily subsidizing this field of promoting use of HPC in Europe. Mark Parsons from Edinburgh, head of EPCC in Edinburgh, said that every pound invested in HPC in Scotland came back to the government in terms of taxes, in terms of other means, by 15 times. So you get 15 pounds per each pound invested in HPC, which is very, let's say, it's great. There are not many return of investments like this one. I will go through this project just briefly, and I will try to explain you. Fortissimo, it's one of the largest projects. There are Fortissimo 1, Fortissimo 2, and Fortissimo 3 on the way. And there is this combined, it's about 45 million euros in this. And it is huge amount of this money goes to experiments. So core partners are building the environment and trying to offer services to SMEs in a, let's say, in a way that SMEs will be happy how to use it. I mean, in the easy way. So try to bring this high technology close to the SMEs. And there are many success stories. There are more than 130 experiments now, and there are about 80% success rate. So we have about 100 success stories out of this. I've brought some booklets here, so please feel free to take them. It's a third it's third revision, and there will be 5 more booklets like this. And you have structured, and you can see from different fields in the factories of the future, in the manufacturing field, how they benefit from using HPC in cloud. Okay, they're really different, you know, from the steel casting to different architecture. I mean, car manufacturing. Of course, we are very proud on 2 success stories. So the first one with steel casting, and this one with new aircraft design. We got IDC award from IDC Excellence Award for both of these projects. So we are one of the few HPC centers in Europe to have 2 awards from IDC. Cloudflow, it's a bit different, and it's very interesting from my point of view. I'm not sure whether the market is mature enough to accept this, but it is about combining different softwares and offering this as a workflow for the end user. So the end user, SMEs, don't have to buy CAD or CAM software, and then again to buy from another software vendor a CFD, and then a PLM and other softwares. But you go to the workflow, and then you have all this installed in the supercomputer, and even you don't have to move the data all the time from your network to the cloud and back. So you leave all the data in the cloud to the provider, and then of course you just pay once and you pay as you go. This is very important. So probably you know, all these projects are about offering innovative business models to the small and medium enterprises. So instead of investing in capital expenditure, we move to the operational expenditure. So pay-as-you-go models. You don't buy the license. You just pay per use, and you pay per core hour, whatever. And then it's much more flexible. You can really bring these services closer to the small and medium enterprises. Last but not least, it's SesameNet. I see at least 2 SesameNet partners. And it is a very important project the goal of this project is to write an agenda, roadmap for European institutions, how to deliver services to SMEs. And we are coming to an end in a couple of months, and we will publish this. We will announce this strategy, announce this roadmap in HPC, help me, in Barcelona, HPC user forum? No, it's not HPC. It's a huge event. HPC Summit. Thank you, Dana. HPC Summit in Barcelona, which probably most of you will attend. And it is about exchanging competencies between HPC centers in order to offer better services to SMEs. Because we found out that many HPC centers, even in the SesameNet project partners, are not ready yet to offer services to SMEs. There are many problems, not just technical or knowledge or money or personnel. There are some legislation problems. So there are many HPC centers which are state-owned, and they cannot freely services to the industry because they are limited. They have 10 or 15 or 20% of the amount of infrastructure they can offer to the market, and even this is tricky in some countries. So what we try to do is also to challenge policymakers, challenge all European countries, in a way that they will promote this and they will let this kind of HPC providers to offer services. What, I'm late? Okay, good. Very important tool which we developed during the SesameNet project. It was basically, we started in Arctur years ago with this, but then with SesameNet we brought this tool to the let's say international level and in fully automated level, and it is about how to assess the potential of SMEs to use HPC in cloud. So there are 2 million SMEs in Europe in the field of manufacturing. I think this is a number. We have 2 million SMEs. And how many of them have the potential to use HPC in cloud? Probably not all of them. Is this 10%? 2%? 5%? I don't know. I'm not sure. Nobody knows, actually. And what we saw in some projects, like Fortissimo and Cloudflow, when you have open a call, it's very hard to find new SMEs. Ask partners from SesameNet. I was really trying to find new partners from Romania, Serbia, Croatia, and we couldn't find any. So we spent a tremendous amount of time, talking with research companies, and we were trying to bring them to the Fortissimo project, for example, or Cloudflow, which means they would get money from Europe to do their simulations. And it's about 100,000, 150,000 euros. It's good money. And what you have to do, it's just you run your simulations in the free infrastructure. And I really couldn't get it, why people are not doing this, why people do not apply. The success rate was 1 to 3. So we found out that most of them are not ready yet. Most of SMEs are not ready yet. And with this tool, we can assess the potential, firstly, and then we can assess the readiness. So this company, an example, one company has a potential, good. We can find out with this questionnaire and all these tricky questions and decision process. And then we see the readiness. Are they ready or not? and then the system would compile the recommendations to these SMEs, what they have to do to come to the better position. Okay, basically what we want to do from the large pool of SMEs, we would like to extract those one with the potential, and then helping them to do this first step, which is very, very high in many ways. So we can offer free services, we can offer trials, or even we can help them to apply for open calls or other subsidies, which would help them to climb this first barrier. And then, of course, when they are up there, it's easy. They can walk, they can run, they can really become success stories. So we see the results. The picture is old. So we have this chart, which means in this quadrant we have high potential companies. If you are here, you have a good HPC potential, but not good enough in cloud. So in terms of security, trust, whatever. So we do the recommendations how to bring you up if you want. And if you are there, we use colors for the third dimension. So the green one is not yet ready, not mature yet to use HPC in cloud. You have a great potential, but you don't use it yet. And when you become yellow, yeah, you are kind of ready, and orange, it's ready to eat. Okay, so what we would like to achieve with this, that many HPC centers in Europe would have this kind of sign. Welcome SMEs. We are ready. We can offer you services. Unfortunately, we cannot say nowadays that many HPC centers are ready to offer services to SMEs. Okay, thank you very much. I'm ready for your questions. No. Yeah, I look this in other way. You saw president with me, yeah.
Anyways, I wonder about a sort of psychological aspect of this. Probably there are SMEs which could rely and could use the HPC services, but are just not aware of it. So have you been able to persuade them actually sort of opening their eyes to this?
Yeah, we do for a living this. 80% of our revenues comes from offering services to the market. So what we have to do, we have to build the market, build the demand. So we are chasing for companies, and we are trying to build the demand. At a certain stage, we hope when they will decide to jump in this pool, we hope they will jump in our pool, and we can invoice them for our services. But it's not easy. It's a lot of 2 years of work before you start charging, and it's a high risk also. That's why we really appreciate that we are involved in so many projects. We can offer some more.
Most of the large HPC centers are partially industrial funded and partially public funded. Can you tell us some examples of those centers that change their ways to be more adaptive to things?
Is there anybody from HLRS here? No, good. So I can talk dirty then. No, HLRS, Mercedes-Benz, whatever, BMW, it's Munich, okay, Mercedes-Benz, high, industry, a lot of investment. It's tier 0 price, it's hundreds of millions. Are their SME ready? Not sure. So if you are Mercedes-Benz and you have a, I don't know, a million cores there for your simulations, would you like to, offer some services to SMEs with this? No, and they are not ready even to. They can do this because they are partially state-owned, and but they are not ready. And I talk with Cineca, I talk with Barcelona, I talk with all centers, and they have, they would like to do this, but it's not the crucial. They will not make enough money for living in offering SMEs. So probably we are not yet there. I don't know if I answer your question, but
So you see the smaller centers coming up with this approach, and then the big centers
yeah,
adopting the approach.
yeah, because it's a tough work. It's not easy, and in the big centers, they have a bunch of excellent experts, and they don't really want to lose their time with beginners, with SMEs, and then at the end they will charge them 10,000 euros. It's not a big money, so I think it's an opportunity for smaller, agile centers. So what you see, we didn't buy a supercomputer. We bought a hyper-converged computer. Whatever does it mean? I'm not sure, but we have to be very, very flexible. And we are used to, when you offer services to SMEs, you have to be aware that you will change your configuration all the time. Try to bring closer to the needs of SMEs. Okay, thank you.
Thank you very much for this interesting presentation. And now we have a presentation by Magister Marko Bohar, who will be talking about the electronic industry and the process of digitalization. Marko Bohar is from the National Chamber of Industry and Chamber of Commerce and Industry, and they are actually also partner in InnoHPC consortium, and will also participate later at our roundtable.
Hello everyone. I'm also within the Chamber of Commerce from Electronic and Electrical Association. So to be a member of this project is for us, let's say, of strategic importance, because we are currently see our industry on the verge of being able to access this kind of technology and being able to apply to their needs and to gain specific market advantage on it. So to basically start, what is electronic and electrical industry in Slovenia? These are general figures. There's up to 600 companies, up to 28,000 employees, and up to $4 billion of revenue, of which is more than 75% in export. The electronic and electrical industry in Slovenia is a component industry. So we are not producing products for an end customer. In majority, a couple of companies do, but the majority of the companies are component industry, and they are very well situated in a global value chain for buyers like Siemens, Bosch, and even from automotive industry, BMWs, Mercedes, Volkswagen. And so these are the top companies that are buyers for our industry. And to better understand this, in the last couple of years, there was huge fight going on in these supply chains, and only the best survived. So all the companies here are niche producers of specific components, but they are usually the top producer in the world of that component. So these companies are now state-of-the-art companies. They are producing components, but they are doing it on a state-of-the-art way, and they are up to the speed as far as technology and everything else is concerned. There are companies all over Slovenia, and these are only the major ones. So there is no specific region in Slovenia which is devoted to electronics and electrical industry, so industry is everywhere. And there are a lot of companies still growing here in this region, in this area as well. We did a project which were dealing about Industry 4.0 and the technology readiness of the electronic industry, and how is this industry adapted to the digitalization. And the survey was done on quite a large number of companies, and the result is pretty much accurate. And it says that over 61% of the companies see themselves as very high on a digitalization level. So they understand the technology. They follow all the technologies which are the backbones of the digitalization, up to big data, up to simulation, additive manufacturing, mechatronics. But they are slightly conservative as far as investing is concerned, and they are investing primarily in robotics and mechatronics currently. And in cybersecurity are the fields where the most investments are currently going on. This is in sync with the fact that this is a component industry, very lean, organized companies, and they are doing specific investments just to make their position within the value chain stronger. What is also interesting is when you look from the Industry 4.0 perspective, and I'm going to speak about this only from a business perspective. There are two revenue streams in Industry 4.0 for each company. One is attached to additional revenue from new products, and the other is from gaining lower cost and efficiency from the existing business model. And from these two pillars, the Slovenian companies are basically on the verge of trying to assess the benefits of Industry 4.0 on both pillars, because on the automatization level, all the Slovenia's companies are up on the technology of art that is accessible on a market. So they have informatized the production. They are controlling the production through central management system. They are feeding the data into EPR systems. They are doing everything what possibly can be done right now in a production to be fast and to be as cheap as possible. On the other side, since we are components industry, there's a lot of need for new products. So they want to develop new products, they want to sell new products, but they don't have currently a lot of ideas how to do that. And the market is forcing them to think strategically into that area. That's why at least the large companies are already starting large venture capitals initiatives in Slovenia. They are building startups along their side, or even within the company. They're doing spin-offs. They're doing various stuff to bring new products to the companies. And this also is in sync with the value drivers which are within the Industry 4.0, and this is where the Industry 4.0 gets serious in our industry, because they are already looking not in a sense, which my predecessor already said, not in a sense of technology as far as Industry 4.0 is concerned, but strictly from business point of view. And as you can see, there's a lot of value that can be achieved from specifically from fields like forecasting, from reduction time to market, from maintenance cost and machine downtime. And you can guess here that we are getting into the area of high performance computing where this can be achieved. So these are the motivators currently for Slovenian companies to think how to get the additional revenue and how to basically jumpstart to this digitalization wave. As far as the understanding of Industry 4.0, we've already heard explanation today. We are not talking here anymore about automatization and informatization. We are talking here about digitalization, Industry 4.0. So every new technology from ICT perspective, which is going to be introduced in a company, needs to change the existing business model. That's the digitalization. If you are not changing the business model, you are doing informatization or automatization. So you need to bind the change to the business model. You need to focus on a customer interface, and you need to basically think out of the scope. And in terms of how do you include the technology in this thinking, the Industry 4.0 delivers an answer, and these are cyber physical systems. This is a new term. It's a general term which basically includes all the cyber technology with the existing physical technology into one new product, but at the bottom line, by changing the business model. And to be even more specific what these cyber physical systems are, it's not a new embedded system, it's a system that can sense, think and act on its own. So this is the idea behind Industry 4.0. This is the final goal. This is what we are all looking for, and this is where the main benefit on the market will be. So the main question is, how do you get from sense to think and to act? How do you do that? And to make it even more interesting is everybody is doing this sort of brainstorming right now, because this technology is available to everyone. So everyone is currently looking for the best solution. Everyone is looking for the best way. And the time is money here. So the one which is going to be the fastest will be the winner. And from my point of view, high performance computing is not an emerging technology. It's already, let's say, a technology which is a very important one, at least if you see the latest development on American side, because they are subsidizing a lot of HPC related projects, and they don't subsidize projects at all in America. So since HPC was recognized as a technology, as one of the pillar technology of new reindustrialization, this is of great importance for us as well, and we would like to be part of the development of new ecosystem that could bring this technology to our company. So it's the computational power that is of course of interest, but apart from simulation, which are already known and are tackled by a lot of project that my predecessor mentioned, there is one particular area that I see and where we see the signals that will be even more important in the future is predictive analytics within Industry 4.0. So if you currently see a company, let's say a company in Slovenia currently is producing 70,000 products for their customers. They have it on their list, and the customer can order one of those products. They need to reconfigure the production line within 4 weeks and deliver to the customer 100,000 pieces of that product within 1 month. On the other side, it takes 4 months to buy all the needing supply to produce that 1,000 pieces. So they are already using a very complicated business modeling systems to try to predict what are the orders going to be for the next 4 or 5 months, so that they can have the needed supply on stock. But this is a very heavy computational task to do, and they can only do it now on the way that it's about 94% accurable. They want to achieve 98%, but they need to run a lot of simulation. They are already building a virtual power plant simulation so that they could play with different configuration of production systems. They could play with different machines, that they could test a new machine, the reconfigurability of the new machine before they even buy it, so that they can see if this will be a benefit to them. And with those cyber-physical systems that were mentioned before, a lot of new connectivity will come in place, a lot of new data will come in place, and even larger analytic capabilities will be needed. So in that sense, when we try to build now a business case for companies, because one approach is, of course, to actually try to make them excited about high performance computing. The other is, of course, create for them a business persuasive, let's say, pitch. Why would they even consider this technology? Is because these are the direction that we are currently going on. There's a lot of already existing use cases that can be economically validated. We need, of course, build a lot of additional use cases, because use cases are the one that are the major attraction point for most of the companies, because they can relate their issues through those use cases. And we have a lot of use cases as far as modeling is concerned in automotive, in aerospace product development. And then we have a lot of additional benefits in data analytics, but those use cases are not so developed so far. And there's also a very clear cost structure for R&D development already in place. So when you add this with the latest numbers from IDC, that each euro invested in HPC on average returned 867 euros increased revenue and additional 69 euros in profits, and that 97% of companies that have adopted HPC said it could no longer compete or survive without this. These are the data, business data, that you can go to the CEO and try to talk to them. Why is this important? This is from my side. As I said, our goal is here to add this high-performance computing to big data and to other pillars that we are building within our digital transformation activities from our company. For our companies, we are also active within a smart specialization in our country. We intend to build a cluster of companies for smart manufacturing, And HPC is definitely going to be one of the technologies that we are going to push to this cluster. Thank you very much.
I was told by our computer engineer that questions are not heard in our streaming. This is why I took this. So we heard that SMEs in many cases are not ready. So my question is, how is your perception of the situation in the industry that you're covering? And what are actually really the concrete steps you mentioned towards the end about the clustering initiative and so on. So what are the, let's say, the concrete foreseeable plans to do in the future, let's say, to make HPC for SMEs a business for Tomi or for us?
Yeah, this is something that it's a $1 million question, so basically. But I have a couple of the ideas, and these are only my ideas since I'm also a computer engineer and my background is telecommunication. If we see the parallel from telecommunication side, so let's say, let's transfer ourselves from high performance computing to the telecommunication. Around the year 2000, the telecommunication was the big hype. So everybody was talking about it. There were huge companies providing services to the industry as about telecommunication, and they were happy to be just telecommunication companies. If we look to those companies right now, there are no telecommunication companies anymore. Those telecommunication engineers, and I was one of them, were forced to start think about and start to learn about domain know-how of the specific domain and apply all the telecommunication knowledge to that specific domain. Nobody was buying from that domain a telecommunication technology or telecommunication expert. So they were just waiting for the telecommunication expert to step down from the telecommunication domain and join that specific domain. So they brought the expertise of a telecommunication expert to, let's say, to energy distribution, to smart cities, or to whatever. So I think that the high performance computing is going to have a similar transition, but there is one problem. Everything is happening faster right now. So the telecommunication had 15 years time to do that. The HPC had only 2 or 3 years to do that. So it's going to be much tougher. But if I'm trying to look at the let's say first an engineer in a normal Slovenian company, this engineer is already 120% booked with the current activities. And if he was not educated about HP, high performance computing on a faculty, he will not have time to learn this on this job right now. He needs to have an expert sitting with him on a daily basis if there's any chance to adopt that technology quickly. This is one fact. The other fact is, if you looked at the SMEs, SMEs are normally not companies talking about technology. Those are companies are talking about markets. They are talking about market ramp up. So you either bring them additional market or you bring them partners that can deliver technology. So the language that you talk to SMEs is they are talking about how they can survive the next month or the next year. So they are usually not thinking about doing large investment or changing their business model, because high performance computing is generally changing your business model. It changes your time to market delivery, and that changes everything. So to summarize, I see one of the possible ways is to create an intermediate player. So to create a sort of competence center which would buy services from Arctur, but would also provide a buffer of experts that can be used per project, per longer time with the companies. And this can be achieved through clusters, this can be achieved through other means, but I think those intermediates need to come in place, and those intermediates will not probably work with businesses on a service platform, but they will be partners. They will share a risk and they will share revenues. So this is what I see, that's how it's going to work.
Thank you. It seems like everybody's selling Arctur. Thank you. Marko, you mentioned at the beginning that you have like 400 members in your association. Okay. At the end of February, SesameNet will launch the self-assessment tool. How can you count on you that you will trying to encourage your members to fill this form? It's free to go through the process. Can we count on about 100 of your members? Just say yes, it's okay. It's broadcasting, it's all in video. Thank you.
We are currently already trying to motivate all our companies to join this Industry 4.0 wave. And as soon as you go to the company and start to explaining what's the issue, you need to have an answer prepared how to address that issue. So high performance computing, big data analytics, and Internet of Things are three technology pillars that we want to push to our companies so that they can see there is a solution available and they start looking into this direction. Especially, as I showed previously, especially during this development of new products, because we cannot get a lot of additional gains in the optimization of the existing business models. So what we are trying to achieve is, and this is 2 steps that needs to be done here in Slovenia, but I think it's in Germany, in Mittelstand, it's practically the same. The companies are very reluctant to work with one another, not because they don't like each other, but because they are not generally not used to do that. It's basically that they are operating in different niche market, in a different time to market, time spans, and it takes a lot of adjustments if you want to build a good and effective partnership. So you need to have those intermediate buffer zones where everything can easily come together, and clusters are one of them, and our specific cluster of smart manufacturing will be featuring this kind of stuff, and we'll try to promote that. So to answer you, yeah, I'm very much interested in your questionnaire. I will add it to my questionnaire about Industry 4.0. So yeah.
Okay, thank you very much. Now we will give the floor to Dr. Tomáš Karásek. Did I pronounce it correctly? Dr. Karásek is from the IT for Innovation, Ostrava University, and their center is actually something that in Slovenia we don't really have, if I understand correctly. It is the national supercomputing infrastructure, which the Czech Republic decided to allocate to Ostrava, not to Prague or Brno. In Slovenia, if we have it, it will be in Ljubljana, we know that. So, sometimes Apple computers are too good for these cables.
Oh, yeah. Doesn't work.
Mhm.
Just 1 minute.
Thank you very much.
I have to change it to 5 because it's green.
Okay.
What are you looking for? System properties. Oh, it's in Polish. Nice. Display. That's this pi. This one, not hertz. 50 hertz pi. Okay, that's it.
Still doesn't work properly.
Did you save the settings? No, it is. When you go full no, look, when you go full screen, it said something.
Mm-hmm. Okay. Now it's supposed to work. Okay, now it's working. Thank you very much. So good morning, ladies and gentlemen. As the board mentioned, I'm coming from the IT for Innovations, which is the National Supercomputing Center in Czech Republic. It's located in the Ostrava, and we belong to the Technical University of Ostrava. In our mission and the vision, the collaboration with the industry is hardly written, because we don't do only the science, as the board mentioned. Some centers, they do just the science and they doesn't want to work with the industries. In our case, it's almost opposite. We foster our research towards the industry, and we seek what the industry wants, what is their need, and how we can help them to do their businesses in the better way. We have a twofold functions. The first one is to operate the biggest supercomputing infrastructure in the Czech Republic, and the second one is to pursue the research in the several domains, which I will show you later on. When we purchased our second supercomputer, you just saw it on the previous picture in middle of the 2015, we were number 40 in the world. Right now we are 67. So it's 1.5, almost 2 years, and we fell down about 17 positions. This shows you how this area is rapidly progressing. The supercomputers are building every single day, and twice a year this top 500 is updated. The largest or the most powerful computers are in China, followed by the US. In the Europe, it's the Switzerland, and I think the Poland is quite high as well. To operate this infrastructure, you need quite a huge facility. Basically, 40,000 euros is spent every single month for the electricity itself. In our case, it's really hungry for the electricity, and when the electricity bill comes, our director cries because he has to forge for the large amount of the money. So we have special infrastructure. On the left down pictures, this blue thing, it's the power generator. It could keep our supercomputer for 2 days burning the diesel when the electricity is down. So we need quite a large facility. We have the dedicated building for it. In our room there is a lowered oxygen level down to the 16% of the oxygen into the air, so there is no fire spreading. Actually, you can't start the fire there. You can try to match the lighter, but it won't go on because there's just not enough oxygen to do so.
So basically we have special facilities for our supercomputer, and apart to giving the computing cycles for the researchers from academia in the Czech Republic or across the Europe, because we are the part of the PRAISE, and we are giving our resources for the PRAISE member through the DECI course or through the SHAPE program, which is designed for the small and medium enterprises. We do the research, and we use the computing cycles to do the research for the companies. On the following pictures, I will show you what we're doing in IT for Innovations, what kind of the services we do we offer for the companies, regardless of their size, SMEs, large companies, national, multinational, and so on, so on. The one area which is very popular, especially among the small companies, is numerical modeling and simulations. Their biggest obstacle to go for this kind of technologies is they don't have a people. They don't have a people to do even the numerical modeling and simulations. They do the manufacturing, they do it well, they do the design of the products, but they don't have the engineers to do the simulations and so on, so on. These are the pictures what we can do in terms of the computational fluid dynamics. We can do the classical things like aerodynamics of the car, because in Czech Republic we have a huge industry, which is the automotive industry. Škoda, Citroën, Kia, Hyundai, they have the factories in the Czech Republic, and some of them, like a Škoda, they have even the research centers in our country. So we do external aerodynamics of the cars, which is basically done also at the HLRZ, which Tomi mentioned. They do it for the Mercedes, for the Porsche, and so on, so on. We do the flow over the large areas, which is important for our authorities, because the pollution is a big issue in our country. So we do the CFD simulations over the large areas to give them the idea how the area is affected by the pollutants from local sources or from the industries, etc. We could do also smaller things, but like or heating, or the burning process could be simulated. So we do the modeling parts. Here you can see several pictures, just the illustration pictures from the medical, which we are doing the implantates for the bones. When your bones break, we can simulate the implantate for the surgeon, which one is the best to use, or was the position 2 or 3 screws, and so on, so on. There was the question about the validating of the models from the crash. On the top side, not the crash test of the car, but it's the simulation of the crash test of the train passenger seat. We have the project with the small company, which is producing those seats, and they're trying to penetrate the UK market, where they have this very strict rule that every single seat must be certified by the physical crash test, which is very, very expensive. We do those crashed virtually in the supercomputer, and we give the advice to engineers what to change. And those virtual tests were basically validated through the physical experiment, and we passed. And our guys are very, very good. If they say to engineers, okay, this seat will pass, this design will pass, it will pass. If they say no, there's something wrong with this, it won't pass. They believe us, and then they won't send this seat to the testing, basically. So we are replacing the physical tests by the virtual one, and we are very, very successful in it. Apart of using, doesn't work. No. Apart of using the commercial codes, we also use the open source codes. The reason is very simple. we cannot allow too many licenses of the commercial codes. Codes like Abacus, LS-DYNA, they are very, very expensive. Our supercomputer has 22,000 cores. If you pay, for example, for LS-DYNA 150 euros per core per year, you can do your math how many euros you would have to pay to utilize the full supercomputer. But if you use the open source codes, you can use as many cores as you want. You can go for the hundreds of thousands, as we did in the US. We tested our codes on the Titan, and we used about almost 250,000 of cores. If we use the commercial code, it won't be basically possible because we can't pay such a money. And this is the big issue especially for the SMEs. They cannot afford to pay for the licenses, and we can't do that for them. So basically, we try to help them to use the open source codes in their day-to-day businesses, because they are for free. They have the large communities of the researchers, of the developers. So these codes are basically tested. They are proven to be correct, and they are for free. So that's the huge advantage, and we help the companies to use them on the supercomputers. And the one very popular buzzword is the personalized medicine. It's have been here for 10 years, and it's very, very popular those days. Basically, if you come to the doctor, they do the CT or MRI to you, and they know a lot about you, but they know it in the 2D. But what we need, and what the surgeons need especially, are the 3D models of your inner organs to plan the surgery properly. And the huge advantage is we save the time. They can do it right now using the existing technologies, but it's very labor extensive. The radiologist must sit through all the scans and do it manually and mark the organ and create a 3D model of the liver or of the lung, which will take really long time, several days. So basically, with our technology, we can do it semi-automatically, and it's much faster, and it's the precision is really astonishing. So basically, we are going towards the personalized medicine and basically analysis of the images and so on. These are the products we can offer to the companies who needs the result of simulation, results of the image analysis, and so on. But there are some companies who are developing the algorithms. They're developing the solvers, they're developing the software. And for them, and especially for our own purposes, we are focusing on highly parallel algorithms. The reason is very simple. The serial algorithms or badly or poorly written parallel algorithms will basically fail on the supercomputers. If you employ more than thousands or more than 10,000 cores, if you go for the 100,000s, your algorithm or your implementation must be robust and must follow the so-called linear scalability. It basically says in the business words, on the top you paying a certain amount of the money, and in the bottom you pay the same amount of the money. But the time it will take to deliver your results is just the fraction of it, from 7 hours to 7 minutes. So if it scales linearly, you just basically pay the same amount of the money, but the time you have to wait for the results is the fraction of the original time. But if your algorithm is not following that linear curve, you will overpay and you will wait for ages. So that's the reason why we basically focus on the highly parallel algorithms. We have our own solver, which is in the middle, because we don't have the guts go for the pre-processing, do all the meshes and stuff like this. We leave it to others like ANSYS or other commercial codes. We are not that good in visualization as Insight or Visit or ParaView, which is free for use for the community. We focus on the solvers to solve the equations and to deliver the results. So we focus on this one, and I would say that we are very successful in it. We have several implementations for coprocessors, for the GPUs which you might have, and so on, so on. Some companies come to us and they have the algorithm, they have the implementation, and they would like to optimize it. For example, for accelerators, Xeon Phi, which is the latest one, and we are the second largest installation of the Xeon Phi accelerators in Europe. We optimize those algorithms, or we optimize the optimization so it uses the accelerators more efficiently, and we basically deliver the optimized code to the company, and they can use it for their own products. You might ask, what do we do in the data analysis? Because the big data is the buzzword. It's here for a couple of years now, and to do the data analysis, it's very important. Yeah, we do the advanced data analysis through different data and so on, so on. Data sets. It's quite advanced statistics using the power of the supercomputers. Multi-dimension data sets in the time and so on. We do the simulations in the different domains, the traffic, mobility. What else do we have here? We use the models to simulate such things. And because those simulations are mainly for the people who are not very familiar with the HPC, who doesn't know what the HPC is, we basically created for them, we call it HPC as a service. They choose the inputs which are coming from different sources. They choose what they want to do with those data, and we give them the results. And they have no idea that the supercomputer is behind. And I think that's the perfect solution for the people who doesn't want to deal with the command line, who doesn't want to study what the supercomputers are about. Is it running on the Windows? No, it's running on the Linux, and so on, so on. Basically, HPC as a service is the service, basically for the people who doesn't want to know about the HPC, and we use it for the disaster management, for example. This is our project Florian Plus, which is for the decision makers when the flood will come. There are what-if scenarios, there are traffic, there are mobility, how the people are moving, what roads are cut off due to floods, and so on, so on. And this is for the rescue services, for the decision makers, so they have no time to do all the HPC mumbo jumbo stuff. They just have to look at the nice pictures and take a decision. So these are the things which we offer for the people who has little knowledge of the HPC or no knowledge of the HPC. If you are expert, we just rent you the computer cycles, and you can use our supercomputer up to the 20,000 cores, and you can do whatever you want if you pay your money. So basically, we are renting the cycles. We can help you with the basic support, because every single HPC infrastructure is a little bit different, but we will help you go through, and our staff will help you with all the stuff. But this is for more advanced users, and no SME in the Czech Republic is ready for this one. We have to give them the more advices than that. We don't have any SME which will just come and use it as it goes. This is just the logos of the companies we are collaborating with. There are big companies, small companies, local, multinational companies, and we are, through the years, we are working with them very closely. We are also very proud of the fact that the Intel decided to grant us for the Intel Parallel Computing Center, which means we have 2 years grant, and we have access to the newest technologies from the Intel, which are not on the market yet. we are porting and implementing our codes to their new hardware, and so we have the competitive advantage over the other researchers because we have access to the systems which will be in the market in 1 or 2 years' time. We are also very successful in the European projects. We have a couple of them. Sesaminet was mentioned here. PRAISE is the consortium of the all major, except of the Switzerland, all major HPC centers in the Europe, and REDX and the Interreg are other HPC projects we are collaborating with. So that's another area where we can help the companies to get the funding. You know, we can bring them aboard for the Horizon projects, and we did for one local company, but most likely we go for the national projects. The biggest issue with the SMEs, or in general with the companies in Czech Republic, is they rather go for the funds from the government than go for their own pockets. So first they ask which grant we can go for. We have several of them in Czech Republic. The national one from the government, from the local governments, and even from the Ministry of Trade and the industry. They have their own grants for the companies to be more innovative or to get the money for the applications. So if the company comes, we can help them in such a way because we have experience how to apply for those grants, and we are quite successful. So this is just the overview of what we do in the IT for Innovations, how we work with the industry, and if you have any questions, I would be delighted to answer them. Yes, there's one question. Thank you. Okay, sorry, thank you. I'm not an expert in the big data, so I won't be able to answer your question, but I think we use our own in-house codes for the big data analysis. And how big data? There's a question, what is the big data? If you can transfer it through the internet, it's not a big data. That's what I heard on one conference I attended recently. So basically, maybe the big data are those data you take your hard drive with you, you travel to the destination, and that might be the big data. But I think we deal with the data in terms of the hundreds of terabytes. Our storage is, if I'm not wrong, about 3 petabytes in total for the whole supercomputer.
Okay, now I would like to invite you for a short coffee break.